All right, so today we're going to be looking at lesson 641, which is titled Choosing a Strategy for Solving a System. It says, what is the best method? So we've learned technically four methods for solving systems. And today we're going to look at some equations, and we're going to decide which of those methods would be best, or in our case, which one's the fastest, which one can get us done the most quickly, right? All right, so question 112 says, Erica works in a soda bottling factory. As bottles pass her on conveyor belt, she puts caps on them. Unfortunately, Erica sometimes breaks the bottle before she can cap it. She gets paid 4 cents for each bottle she successfully caps, but her boss deducts 2 cents from her pay for each bottle she breaks. Erica's having a bad morning. So 15 bottles have come her way, but she has been breaking some and has only earned 6 cents so far today. How many bottles has Erica capped, and how many has she broken? Write a system representing the situation. So I picked X to represent the capped bottles, and I picked Y to represent the broken bottles. Those are the two things we're going to have here. How many bottles passed her way total? 15. So one of the equations is just X plus Y equals 15. We have some of each. We don't know how many of each, so we're just going to say X plus Y equals 15. The other equation is going to have to do with what? Money, pennies. She's getting paid pennies for doing this job, which apparently she's having a rough morning, so she's breaking some bottles. So mathematically, if her boss is deducting 2 cents per pay bottle, how would we say that mathematically if he's deducting? Subtraction or minus, okay? But if she successfully caps the bottle, she gets how much? 4 cents. So she's going to get 4 pennies or 4 cents for every capped bottle, but she's going to get deducted 2 cents for every broken bottle. And it was a rough morning, so she's only getting a total of 6 cents, okay? We need to take these two equations and solve them. So part B says, solve the system of equation using 2 different methods, substitution and elimination. Demonstrate each method results in the same solution. Okay? So first, we're going to solve the system by substitution. So if you look at the 2 equations, one of them looks easier to solve for one of its variables. Which one? Equation 1 or 2? 1, right? So I'm going to take that first equation of X plus Y equals 1, and I'm going to subtract X from both sides so that I get Y equals 15 minus X. Then I'm going to take that 15 minus X and I'm going to substitute it into equation 2 where the Y is at. So it looks like this, 4X minus 2. Then in parentheses, I'm writing that whole expression, 15 minus X equals 6. Then I drew my distributing rainbows. So I've got 4X, and then negative 2 times 15 is negative 30. Negative 2 times negative X is plus 2X, because a negative times a negative is a positive. Then I look for like terms. Anybody see our like terms? No? No like terms? The 4X and the 2X, right? 4X plus 2X is what? 6X. I'm going to add the 30 to both sides. So 6 plus 30 is 36. And then hopefully you guys can do that part in your head. Divide both sides by 6. And 36 divided by 6 is 6. Then we're going to take that 6 and plug it back in. I thought it was easiest to plug it back into equation number 1, right? It looks the easiest. Always pick the easiest one because you're less likely to make a mistake, right? Okay, so you're going to say 6 plus y equals 15. Subtract 6 from both sides, and you get y equals 9. Right? That's solving using substitution. Now we're going to solve using elimination. Bless you. For elimination, we need to have opposite coefficients. Okay? So right now, if you have x and 4x and y and negative 2y, you don't have opposite coefficients. So I'm going to multiply the second equation by 2. So I'm going to say 2 times x is 2x, 2 times y is 2y, and 2 times 15 is 30. That way, I have one of my variables with opposite coefficients. Which one has opposite coefficients? The y does, right? See how it's negative 2y and plus 2y? They're opposite, so they're going to cancel. Then we combine what's left. So we have 4x and 2x, which is 6x. Combine the 30 and the 6, which is 36. Divide both sides by 6, and we get x equals 6. This should sound really familiar because it's almost what we just did, right? And then this part is the same as over here. You still get y equals 9, okay? So does it matter sometimes whether you use substitution or elimination? No, pick whichever one is going to be easier or faster for you. In this case, do you think it would have been faster to use substitution or elimination? Elimination was slightly faster, right? Slightly faster. But sometimes substitution is faster. Just depends on the equation. Equations. All right. So problem 113 says, for each system below, which method would be the most efficient and convenient? The substitution method, the elimination method, or setting the equations equal to each other, the equal values method. Okay? Do not solve the systems yet. Be prepared to justify your reasons for choosing one strategy over the other. Okay, so here's A through D. Okay, we're going to look at these equations and we're going to decide which method you think is best. We're not going to solve them till the next page. Okay, so part A. Part A, we have x equals 4 minus 2y and 3x minus 2y equals 4. What method do you think would work best on that one? Substitution. Somebody says elimination. Anybody else? What do you think? Yes, because the first equation is already solved for x. This one is lending itself towards substitution. So underneath A, write the word substitution. Part B, we have 3x plus y equals 1 and 4x plus y equals 2. What do you think about that one? Destin. Elimination. Why?
Because if you multiply the bottom equation by -1, the y is
perfect. Great answer. Awesome. So make one of them -1, multiply one of them by -1, and then you're going to have opposite y's. All right. Part C, we have x equals -5y plus 2 and x equals 3y minus 2. What do you think on that one? Yeah, substitution or the equal values method. See how they're both set equal to x? That means you can take those two expressions and set them equal to each other. So you're going to write equal values on that one. Equal values is technically substitution, but this program calls it equal values method. Okay. Part D, we have 2x minus 4y equals 10 and 2y plus 6 equals x. What do you think about for D? It's kind of tricky the way it's written, but some people say substitution, yeah? Substitution, why? Right, because you already have one of the equations set equal to x. So you can just take that expression and plug it in there, okay? All right, so write substitution. Now let's look at E through H. Question E. D equals 2 times the quantity 7 plus W, and 3D equals 15 times the quantity 7 minus W. What about that one? It's already solved for one of its variables, so what's the best method? Elimination? Yeah, you could use elimination, Justin. You could divide both sides by 3 and do the equals value method, or because the first equation's already solved for D, you could substitute that in for D. So you could say substitution. This one's kind of open for interpretation, but I would go with substitution. But other methods would work well too. All right. F, we have negative 6x plus 2y equals 76. And 3x minus y equals negative 38. What do you think on that one? John? Elimination. Yeah, I think elimination would work best on that one too. What would you multiply by? Yeah, I'd multiply the bottom equation by 2. Yeah. All right, let's look at G. G, we have 5x plus 3y equals negative 6. And 2x minus 9y equals 18. What do you think on that one? Elimination. And what would you need to multiply by? Top one by 3. Good. All right, last one. H, we've got x minus 3 equals y. And 2 times x minus 3 minus y equals 7. What do you think on that one? Oh, I just showed the answer. Substitution. Yes. All right.
Have you seen that thing? Have you seen that? I'm sorry.
Oh yeah. You're not using enough those coupons, guys.
Don't judge it. Like your answers.